The Bugatti Chiron has 10 radiators. 2 at the front, 2 on each side managing engine coolant, 2 charge coolers managing the air temperature from the turbochargers, and the rest handling overflow transmission and supplementary cooling circuits. 10 separate heat exchangers, all of them required to manage the thermal output of a 1,500 horsepower engine running at full load. Several of them were destroyed in the crash that wrote this car off, and Bugatti would not supply replacements. Parts unavailable to independent owners. No supply chain, no alternative through official channels. So Bob built new ones from scratch using Honda Civic radiator cores he sourced independently in approximately 3 days. Not 3 weeks, not 3 months, 3 days. And when those radiators were fitted to the Chiron, when the hoses connected with the brackets bolted and the cooling circuit completed, they worked. Today I want to tell you exactly what Bob did. Every step, every decision, every moment in a 3-day process that replaced parts Bugatti declare impossible to source independently. Because what Bob did in that machine shop is one of the most impressive pieces of independent automotive engineering ever documented. Meet Bob. He is not a Bugatti certified technician. He has no manufacturer endorsement, no official relationship with any car brand that would imply authority over how their vehicles are repaired. What Bob has is a machine shop, a lifetime of working with metal, and an understanding of engineering problems that does not come from a training manual. Matt Armstrong describes Bob as the most trustworthy person he knows. Someone who approaches every job with the question, what does this actually need, rather than what does a procedure say to do? Bob has already stamped his mark on this Chiron, rebuilt once before. The cracked gearbox mounting bracket, the part whose failure caused the entire car to be split in half, was declared unrepairable by most people who saw it. Bob assessed the material, preheated the bracket, welded the fracture, and fabricated reinforcing infills from cardboard templates, making the bracket stronger than the one Bugatti originally built. E.B. Bob stamped inside the engine bay of a 3 million pound car. The radiators were next, and the radiators were arguably the harder challenge. Here is what makes rebuilding a radiator from scratch genuinely difficult, and understanding that difficulty is what makes what Bob achieved in 3 days so extraordinary. While a radiator is not a complex component in concept, it looks simple. Tubes and fins. Coolant enters one side. Heat transfers to the fins, and airflow carries the heat away while cooled coolant exits. But every single dimension matters profoundly. Tube pitch, the space in between coolant tubes, determines flow rate and pressure drop. Too tight and flow restricts. Too wide and the heat transfer surface reduces. Fin density, the cooling fins per inch, determines heat transfer efficiency. Too low and you have inadequate surface area. Too high and airflow restricts, especially at low speeds. The tank dimensions must match the cooling circuit volume precisely. Hose connections, mounting brackets, fan mounts, all must be located correctly in the car's structure. Bugatti designed these radiators specifically for the Chiron. Specifications live in their engineering database, not publicly available, not shared with independent repairers. But Bob did not have access to those specifications. What Bob had was the damaged originals, bent, damaged, partially destroyed, but still containing enough information, if you knew how to read it, to reverse engineer what the replacements needed to be. Here is the process Bob followed, step by step, because each decision in that sequence reveals something about the level of engineering judgment involved in what was accomplished. This is not a straightforward repair. This is a manufacturing process, from damaged components to functional assemblies, in 3 days. Step 1. Reading the damaged originals. Bob examined the crashed radiators not to repair them, but to measure them, to understand the specification that Bugatti's engineers had designed into the assembly. Tube pitch measured from what remained of the original cores. Fin density read from the sections that had not been crushed in the impact. Tank dimensions calculated from the undamaged ends. Hose connection positions taken from the fittings that were still intact. A damaged radiator that cannot be repaired is still a specification sheet, if you know how to read it. Bob read it. Step 2. Finding the cores. With the specification understood, Bob needed cores that matched it. He went to a specialist supplier, not a Bugatti supplier, but a radiator core supplier who stocks standard cores across a wide range of specifications. The cores he found that matched the Chiron's dimensional requirements were Honda Civic radiator cores. Not because Honda and Bugatti share a manufacturing relationship, but because the physics of heat transfer does not care whose name is on the bonnet. A core with the right tube pitch, the right fin density, and the right dimensions performs the same function regardless of which manufacturer's catalog it appears in. Step 3. Machining the fittings. This is where the machine shop work began in earnest. The Honda Civic cores arrived as cores. No hose connections, no mounting brackets, no fan mounts, just the heat transfer assembly itself. Bob had to manufacture everything else. Hose connection fittings machined from aluminum. Correct diameter. Correct position on the tank face. Correct angle for hose routing. Mounting brackets fabricated to locate the radiator correctly in the Chiron's front structure. Correct clearance to surrounding bodywork. Fan mounting points positioned to accept the Chiron's existing cooling fans, undamaged in a crash. All fabricated from measurements taken from the damaged originals and the car itself. Step 4. Assembly and checking. With cores and fittings prepared, Bob assembled complete radiators. Welded the manufactured fittings to cores. Fitted the brackets. Checked the geometry against the reference measurements. This is the step where most attempts would reveal a dimension that was slightly off, where a bracket would not quite line up, where a hose connection would sit at the wrong angle for the hose to route cleanly. Bob's brackets were on the wrong side on one unit, not because of an error in judgment, but because at 3 o'clock, in the morning on the final day of the build, when the last task was attaching the brackets and the logical position was the side facing you, the bracket ended up mirrored from where it needed to be in the car. Matt's response when he found this, delivered with a particular combination of affection and exasperation that only comes from working closely with someone genuinely exceptional, was that at least Bob had not built the entire radiator wrong. The brackets were flipped. The radiator was otherwise correct. The radiators were fitted to the Chiron. The large center radiator, the primary coolant circuit for the W16, slid between the chassis legs and bolted to the upper mounts. The hoses connected, the overflow pipe routed correctly. The fan bolted to the rear face. Matt's description, everything is lining up good. Then the side radiators, the ones Bob had fabricated from scratch with no original to reference against the side of the car, fitted, bolted, hoses connected. Then came the pressure test. This is the moment that determines whether 3 days of fabrication work is sufficient. Air is introduced to the cooling system through the expansion tank. Pressure rises to the test value, and then either silence or sound. Silence means the system holds. Every weld, every fitting, every connection between Bob's fabricated components and the Chiron's existing circuit, all holding pressure, all sealed. Sound means a leak. They heard a sound, a small leak in one radiator at a point that appeared to be damaged from transit. The fabricated unit caught something during transport to the car. Not a failure of fabrication, not a weld that had not held, but a physical knock that had opened a small breach. Matt's reaction, we come so close. And immediately, what happens next? Not despair, but a plan. Bob welds it. The radiators will be ready. That reaction, the immediate forward movement from a setback that would have stopped most people, is the whole story of this rebuild compressed into one moment. Now here's a comparison that puts what Bob achieved in 3 days in its proper context. Because the question worth asking is not just what Bob did, but what Bugatti would have done instead. Bugatti's official process for replacing Chiron radiators is not publicly documented. No lead times are published, no availability windows posted. What is known? Bugatti does not supply parts to independent owners. Every component flows through authorized dealers. Lead times are manufacturer-controlled. Pricing reflects the complete absence of competition. Mark McCann waited a month to not receive a call back about a gearbox. The radiators, 10 assemblies, several destroyed, through official channels would have meant months of lead time and complete dependence on a supply chain that had already refused to cooperate. Bob was given damaged originals in a machine shop. 3 days. Not a compromise, not a temporary solution. A solution. Honda Civic cores perform identical heat transfer. Custom fittings connecting them to the Chiron's cooling circuit. Brackets locating them correctly in the car structure. One small leak is already being addressed. That is the difference between a manufacturer that controls access and a craftsman who solved the problem. The radiators Bob built will cool the W16. They are already in the car. Bob rebuilt Bugatti radiators from scratch. He read the specification from damaged originals, found matching cores in a Honda Civic parts catalog, machined custom fittings in a machine shop, fabricated mounting brackets from aluminum, assembled complete radiator units, and fitted them to a 3 million pound Bugatti Chiron. 3 days. One bracket was on the wrong side. He put it right. One radiator developed a small leak from transit damage. He is welding it. Bugatti's response to Matt's request for replacement parts. Silence. Bob's response to Matt's request for replacement parts. Done. Tell me in the comments what you think Bob should be paid for 3 days of work that replaced parts Bugatti refused to supply. Because whatever Matt is paying for that invoice is the only fair price in this entire story. Subscribe because Bob is welding the leak. The coolant is ready. Yes, and the temperature test that this entire